Hey everybody, this is Mr. Ainsworth. Let's greet each other properly. Good morning. Hey, I'm with you virtually today in this lesson. Here we are in Chapter 10, Section 2. We're talking about linear growth and arithmetic sums and series Part 2. Okay, we already went through Part 1. This is Part 2, where we take our sequences and we add a bunch of terms up. We're going to call them series or the sums of a sequence. Okay, that's all we're doing. Before we get into the big part of it, though, all right, let me throw a little some teasers at you, okay? What I want you to do, though, before we even get started, pause it if you need to, but I want you guys to have your calculator out because you can use it at all times because the numbers get big sometimes. And to speed up the arithmetic, have your calculator out and put the phones away. You heard me, put those phones away. All right, use the tool that you're going to be testing with and get good at it. Okay, I don't care whether it's the TI-30 or the big TI-84 or the TI-92 or the TI-1000. All right. All right. Just get it out. Here we go. All right. First thing I want you to do is I want you to sum or add all the numbers from 1 to 10. All right. I'm talking about 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. All right. Plus 8 plus 9 plus 10. Sum means add, right? Add the numbers. What's a sum? All right. Go for it. Even use your calculator. Do it in your head or on your calculator. I don't care. Throw a number down. All right, hurry up. You guys are too slow. All right. You should have got 55. 55. All right. All right. Now let's do something a little bit more challenging, okay? And I'm not telling you how I came up with that number so fast, because I didn't even show you how I did it. Because there's advanced ways of doing things in mathematics, right? There always is, and that's why it's good to get smart. Because it did, instead of adding one number or two numbers at a time like you guys just did, there's a fast and easy way you can do it in literally only 2 seconds. All right. And if you didn't even have a calculator, ooh, you'd have to do it all mentally. This would take a little bit of time, especially if the last number is big. So let's tease you a little bit more. Let's take the sum of all the whole numbers from 1, not to 10. No, that's too easy, okay? All right, that's too easy. So let's go 1 to 20. All right. 1 plus 2 plus 3 plus dot 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 plus 18 plus 19 all the way up to 20. What in the world is that? Okay? Go for it. Use your calculator if you want. I don't care. Just go for it, guys. I see you guys. Just don't sit there doing nothing. Come on. Get creative somehow or get working. All right, make yourself proud. Do something. 1 plus 2 plus 3 plus all the way up to 20. Hmm. Let's see here. 20 times 21 divided by 2. You should have got 210. 210. All right. Question is, how in the world did I just do that so fast? Okay, there's got to be more advanced ways of doing things. Now, let's say that I will ask you guys to sum up all the numbers 1 to 1,000. Okay, 1 plus 2 plus 3 plus dot 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 dot. Okay, plus 998 plus 999 plus 1,000. All of them from 1 to 1,000. What in the world is that equal to? Big question mark. Now, if I actually gave you the time in class to do that without any advanced methods, you guys would probably spend a whole lot of time and probably not even get it right because it's so easy to make a mistake either mentally or in the calculator. All right, but luckily for us, there's always advanced ways to do it. And the man who I want to talk about first, Johann Carl Friedrich Gauss. Everybody say Gauss. Okay. All right. Gauss, who you're looking at here. Everybody say hi to Gauss. He was a prodigy and one of the most famous mathematicians of all time. So we'd be really wise to take a look at what he did at such a young age. Now uh, he was from 1777 to 1855. So he was born a while ago, as you can tell from here to here. And when he entered St. Catherine's uh, Volksschule in 1784, let me see, 77, 84. So how old was he right there? He entered school at the age of 77, 84. What is it? Oh, about maybe, how about 7 years? 7 years of age. All right. Uh, when he went to elementary school, during the first 2 years of elementary school, Gauss didn't even take an arithmetic course. I'm talking number theory course because this is a long time ago, guys. They didn't have specific courses like we do, like Algebra 1 and or actually pre-algebra and all that, and then Algebra 1 and Geometry and Algebra 2. They didn't have all that kind of stuff. All right, but they did have some smart people like this guy right here. They were born even back then. All right, he took his first arithmetic course in 1886, and during 86 and 87 school year, right, during the 18th century. During that year, his teacher and instructor, Buechner, okay, everybody say Buechner, asked the class to add the numbers from 1 to 100, kind of like the way I did. Asked you guys to ask the numbers 1 to 1,000, but I was a little bit more ambitious right there. All right, Gauss immediately wrote down the answer. Whoa, check that out. All his classmates were, well, they obtained incorrect answers, okay? But when Buechner saw that Gauss obtained the correct answer, he asked how Gauss solved the problem. Now here he is, very, very young age. All right, and Gauss came up with the answer from 1 to 100, adding those without a calculator, guys, just in his head, just came up with the answer. And here's how he did it. And Gauss replied he did the following, okay? So this is what he was thinking. See, he got creative. All right, creative. Creativity can't be taught. All right, you're born with it. It comes innately with you, and with your 52 cars that God gave you. All right, you are born with a certain level of creativity, and he was very, very creative. So what he did was, instead of just adding two numbers at a time, 1 plus 2 is 3. All right, and 3 plus 3 is 6, and so on, and started adding two numbers at a time because it's a binary operation. No, he thought of a different way because he knew there was a lot of numbers there. And so what he did was, he listed them out. Okay. So he said, well, this is 1 plus 2 plus 3 plus, come on, guys, get your pencil going here. Follow me. All right. Plus 4 plus all the way here in the middle. Let me see, 49 plus 50 plus, 51 plus 52 and so on. Plus all the way to 98 plus 99 plus 100. He visualized these numbers, and he probably did it. Well, historians think he did it this way. Okay, so I'm going to show you how we think he did it historically speaking here, and then I'll show you another way too. That's pretty much the same as how Gauss did it. But he looked here and he saw the numbers here, and he noticed that if you take the first and the last, all right. So he took this one here and the last. Well, that's 101. So they add, and then if you take a look at the second, all right, the number 2 right here, and then 99. Well, 2 and 99 add up to 101. So 1 plus 100 is 101. 2 plus 99 is 101. And if you do it again right here, 3 plus 98, well, that's 101 too. And if you go on the inside here, and the very innermost number here, and you go on the inside, and you look at pairs of numbers, well, they add up to 101 too. Even if you look here, 49 and 52, well, they add up to 101 too. The question is, how many pairs of these do you have? And so Gauss quickly saw this pattern here, and he figured it out really easily. He noticed that 1 plus 100, well, that's 101, all right? That's the outside pair. And then 2 and 99, 2 plus 99, well, that's 101. Let me rewrite this so it looks a little bit better. 101, 101, okay. And then 3 plus 98, that's 101. And 4 plus 97, well, that's 101. And you go all the way on the inside here, you go 49 plus, well, 52. Look at the one in blue here. All right, that's 101. And the innermost pair, 50 plus 51, well, that's 101 as well. The question is, how many pairs of these are there? Okay. How many? Come on, where's my computer? Catch up here. How many pairs, all right, sum to 101? That's the big question. And he's sitting there in elementary school. Now he's very, very young, and he's asking himself this question because he saw this pattern right here. And we think, well, let me see, out of 100 numbers, 100 divided by 2 is 50, so there's probably 50 pairs, right? There's 50 pairs, so 100 divided by 2 equals 50. There's 50 pairs. Okay, so 50 pairs of numbers, and they all sum to 101. So what he did was is that to get the sum total, or the total sum, let me write total sum, you took how many pairs there were, which were 50, and you multiplied it by each sum in the pair. So 50 times 101, right? What is that? Well, work it out. So what's 50 times 101? Now, if you're sitting there just watching, grab your calculator, guys. Do it. All right? Practice with me. Practice winning habits. Come on. And that's 5,050. All right? 5,050. That's the total sum. This is the way historians remember how Gauss solved the problem back in the 18th century, back in 19 or 1784, when he was at elementary school. Okay, you can think of it though another way. This is another way to think about how he solved the problem. So uh, let's come down here and let me represent it just a slightly different way, because uh, it gives you another way to think about it, number one, and also it kind of leads to the quick summation formula that I'm going to use later on. Okay, because we're going to take these ideas and run with them. So here's another way. We can take the numbers from 1 to 100. So 1 plus 2 plus 3 plus 4 plus dot 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 dot. There's a lot of them, right? Plus 98 plus 99 plus 100. List them out. Now what I want to do is I want to write them backwards, okay, and line them up. Okay, so I'm going to rewrite 1 through 100 but backwards, and I want to line them up. So write backwards and line up. Okay, rewrite. This is called a series now. Okay, backwards. All right, and line up terms. Make sure you write that term, or write that down, because what we're going to do is kind of what we did here, but we're going to see Gauss's result in a slightly different way. And this is going to lead to our what's called our summation formula, which is going to allow us to add up a series of numbers very quickly and very easily, even though the numbers are large, and even though that we have a whole lot of them. All right, so I'm going to reverse the order. Here we go. 100 plus 99 plus 98 plus 97 plus dot 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 dot. Okay, plus 3 plus 2 plus 1. Okay, and now what I want to do is I want to add them up. Okay, put a big plus sign right here. All right, and what I want to do is take a look at this, take a look at this, and take a look at this, and take a look at this, and take a look at this sum, and take a look at this sum right here. Take a look at those. Okay, notice that this sum right here is 101, and this one is 101, and this one is 101, and this sum is 101. Oh my God. Okay, dot dot plus dot 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 plus, and again this is 101 plus 101 plus 101. Notice that we have a bunch of sums and they're all 101. Well, if I wanted to add the numbers up from 1 to 100, I can see that there's obviously 100 ones. Okay, if we list out the numbers from 1 to 100, there's obviously 100 numbers. If I rewrite this sum backwards and line them up, I get a new sum, right? So I'm adding up two sums, 1 to 100. So I'm actually counting double here. Okay, so notice that I have 100 of these. 100 of these. Okay, there's 100 of them. So to count the total, instead of using addition, we were taught in grade school, once again, this is a grade school technique, that instead of adding, we multiply, right? Because multiplying is actually just repeated addition. So what we get when we have the total sum here, all right, we got to take 101, you got to multiply it by 100, all right? But here, you got to understand, we double counted. We double counted, okay, and that's not good, right? That's too much. So if we double counted, because we had two sums that equal the same thing, what do we have to divide this by if we double counted? because we're counting too much. By double. Okay? What do we have to divide by? Say it out loud. What do we have to divide by? All right, we got to divide by 2 because we double counted. All right, if we have twice as much here, well, then we got to take half of it. So we got to divide by 2. All right, now when you do that, uh, you can divide here first, 100 divided by 2. All right, that's, ooh, what happened there? That's 50, and then 50 times 101. Well, we already did that up here. Gauss did it earlier. It's the same problem, my God. And we get 5,050. Okay? Now, we have to understand here what's going on. What's an easy way we can do this? All right, what's an easy way? Well, we'll get to that. Okay, so I don't want to spoil it right now too much, but this 101, it was found by taking the first term and the last term and adding them together. The 100, that represents the number of terms. So in general, now I'll just put it out. This is your first term right here. This is your first. Okay, it's kind of like A1 back in the sequence days, or P0 maybe. And this is your last term. Last term. So first, last, right? This is your last term here. And we have 100 of these terms, right? So this kind of looks like n in general right here. So to get the 101, we take the first and add it to the last. So I'm going to just write this out in English. First plus last. Multiplied by 100, okay, that stands for n, how many terms we have. So multiply it by the number of terms, n, all right. And since we double count, okay, we got to divide that by 2. That's how you get the sum of the n terms, okay, sub n, sum sub n, okay? Or what we just say in general, s sub n, where s stands for sum. That makes sense, right? Okay. So S sub n stands for the sum of the first n terms. Sum of the first n terms. That's S sub n. So it's nothing mystical, okay? It's the first plus the last times the number of terms divided by 2. Okay? Say it out loud. First plus the last, all right, times the number of terms divided by 2, because we double count. And believe it or not, that is right there your summation formula for the sum of the sum of terms in a series. It's that simple actually, but we'll do it mathematically here in a minute. All right, everybody turn the page. Let's take a look at a real problem here. All right, and Gauss is cool. All right, he gave us clues on how to do things, but now let's apply it to a real problem and take a look at how to solve a real arithmetic sum problem. All right, a small tractor manufacturer has a 12-week production schedule for his radically new 2008 model. Okay, the plan is to manufacture 3 additional tractors each week. That's probably important. Okay, 3 tractors each week for the next 12 weeks. All right, for the next 12 weeks. All right, that's why you see 1 through 12 up here. First week, right? The 12th week for the first 12 weeks. All right, from the original 10 they produced. Okay, now, so let's keep on reading. These tractors are stored in several warehouses until the release date. If the storage costs are cost $10 tractors per week, that's important too. Okay, look at this, $10 per week. That's the cost. Okay, in dollars, $10. All right, per week. All right, per tractor. All right, per tractor. All right, what is the total storage cost? What is total, keyword total storage cost over the entire, all right, 12-week period? All right, keyword is total. Because you're finding a total, you're talking about the total sum of the costs per week. So you have to add the cost for every single one of the 12 weeks. What in the world would that be? All right, so before we do that, we kind of like probably should get a sequence of values and get a, let's say, an explicit function going on here and get some sequence of numbers here so we can look at it. What is the first week? And well, it's right here. And what is the last week and so on. Okay. All right. Now, the original. So it says from the original 10 weeks. So let's take a look at this right here. It says from the original 10 they produced. Now, it costs $12, or excuse me, $10 per week to store these things. And if they originally produced 10, all right, which is the starting value, right here, all right, how in the world do you get $100 here in the start? Well, if they had 10 originally produced and each one cost $10 to store per week, it kind of sounds like to me, let's see here, looking here, let's just do arithmetic in the margin here. So 10, 10 tractors were produced, and it cost $10 per week to store them. So 10 times 10, well, it sounds like 100, right? So that's where they get the seed right here. This is the seed. This is your starting value. They started with the original 10. It cost $10 per week, so 10 times 10 is 100. Okay, now 3 additional tractors each week per week are added. All right, so what you have to do is you have to add 3 tractors. All right, but really you're not adding 3 tractors, you got to add the cost. So 3 tractors, all right, per week. All right, it costs $10 each, so times $10, it costs $30. All right, each additional week. That's important. So you really don't add 3, you add 30. All right, you got to be careful with that. You're adding 3 tractors, or you're manufacturing 3 additional tractors per week, but since each one costs $10 per week, it really costs 3 times 10, or $30 per week to store these things. All right, storage costs. Storage cost. So you have to understand the problem. Okay, so 100 plus 30 is, well, that's 130, right? Let me rewrite that better. $130 for the second week. So far, after just, after the first week, we got 100 plus 130 is 230. Well, every week you plan to produce 3 more, and that's an extra $30. So plus $30. All right, so $160 in 2 weeks. Add $30 more. Let's put a $sign on that, plus 30. So $190 on the third week, or after 3 weeks. All right, you have to add $30 more again, so 220. All right, keep adding 30. Dot 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 dot. Okay, and the question is, how much in the 11th week and 12th week? Well, okay, let's learn from the past, and let's learn from our preceding lesson in part 1. We know that p sub n is equal to p sub 0 plus d times n. That's our explicit function for arithmetic sequences. Okay, we know that p sub 0 is a seed, and that's 100. So p sub n here is equal to 100 plus d. D here is 30. All right, this is equal to d. The common difference is 30. So 30 times n, the number of weeks. So d here is 30, and n equals the number of weeks, or the week number of weeks. The reason why I need that is because I could list out, and I keep adding 30, and on the calculator that'd be pretty easy to do to get a week 11. But what if I put 50 here after 50 weeks, or 1,000 weeks? Okay, you don't want to sit there all day long with a calculator and keep on adding 30. All right, that'd be boring. So let's be smart. We're mathematicians here. All right, so what we're going to do is we're going to calculate it. So using your explicit function here, P11. Let's see here, P11. We'll put it right here. P11 is equal to 100 plus 30, all right, times 11. All right, we'll work it out. So let's do that. So you enter in 100. Here, let me just clear this out. Let me start over. 100 plus 30 times 11 equals. All right, 330 plus 100 is 430, so $430. So, and then add $30 more, you get 460 here. So be smart. All right, use your explicit functions and use your prior knowledge from the previous lesson. Okay, so we know the seed, we know the common difference, we got the explicit function, we're looking good, okay? All right, so what we need to do now is we have to find the total sum of all these, because it says, what is the total storage cost? Look at this right here, the total storage cost. So let's figure that out. The total storage cost, all right, is equal to the sum of all these. All right, of all of them, all the first 13 terms. And you say, why 13? Well, after 1 through 12 is 12 plus the starting one, that's 13. All right, there's 13 terms here. So what is the sum of all these guys? All right, and I'm talking about starting from 100. What's 100? All right, plus 130 plus 160 plus 190 plus dot 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 all the way 430 plus 460. What in the world is this? All right. Now you can do it on your calculator and you keep on pressing the buttons, but the problem is you don't have the middle terms, right? So without all the sequenced values, you can't just do it by straight addition like an elementary student would do back in grade school. Okay, we're in high school. We're seniors in here. All right, we're mathematicians in here, guys. We got to be like Gauss. So what we want to do is we want to, well, be like Gauss. We want to get creative, and we want to use his techniques and add them up the easy way. So here we go. We're going to write the sum twice, once forward and once backwards. Once forward and once backwards, and then line them up and add. So, and then we're going to take half of it when we're done because we're going to double count. So here we go. The sum going forwards looks like this: 100, and be very detailed here in how you're writing this. So you got to line them up: plus 130 plus 160 plus 430 plus 460. Okay, now rewrite it. Okay, so 460 plus 430 plus 400 plus dot dot dot. Okay, all the way back to 130 plus the original term or first term. You can see it. Woo. Right there. Okay, 130 then 100 back up here. All right, now we wrote the sum forwards. Okay, so this is forwards. This is backwards. All right, and we're going to add now. Okay, we're going to add them up. So here we go. All right, let's sum them up. So what do we get here? Right here, what do we get? Well, let me see. 100 plus 460 is 560. Plus, 560 again. Plus 560 again. Plus, dot, 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 plus 560. Plus 560. Oh my gosh, we're always getting 560, kind of like Gauss and kind of how I did it before. Okay, I'm talking about right here on the preceding page right here when I looked at the Gauss problem. I went forwards and then backwards and I saw the sums. All right, and because we double counted, we divided by 2 afterwards. Okay, so we're going to do the same thing here. We have how many terms there? So we've got to figure out the total. So the total here, all right, the total sum, this total storage cost or the total sum would be equal to, well, 560 times something, right? We got to figure out how many have. So how many of these do we have? How many? Okay, how many? Question mark. And you got to be careful, it's not 12, all right? We have P1 through P12 is 12, all right? But you got to figure out, we started counting at 0, not 1, all right? So you got to add the extra terms. So it's always n plus 1 terms. So it's 13 terms. Okay, 13 terms. So because of that, we got to take 560 and multiply it by 13. But remember, we double counted here. We double counted. All right, and because of that, we have to divide by 2. All right, take the sum, all right, and divide by 2 because you kept double counted. You don't want twice as much, so you have to adjust it or readjust and go back to normal. All right, so let's figure this out. On the calculator, just bust it out. Like I said, you're going to need it because the numbers are getting bigger. So 560 times 13 divided by 2. Just type it in directly. 560 times 13 divided by 2 is 3,640. All right, 3,640 for the total storage cost. Total storage cost, okay, over the weeks. Okay. So there you go. You just have a really good idea of how to solve these problems. Remember 100 here. Let me go back and I'll restate what I did in this problem and compare it to the Gauss problem. we take the first term. So get your red pen. We take the first term here. We take the last term. We added them to get the sum. So this right here, this 560 was found by taking the first plus the last. Let me highlight that better here. You take the first plus the last. And to get this term here, and you multiply by how many terms you have. So this is first plus last times how many terms, and divide that by 2. First plus last times how many terms you have, divided by 2, because we always double count. That's how you solve these problems quickly here. So in summary here, this is a summary. All right, if you're going to sum n consecutive terms, this is important, consecutive terms of an arithmetic sequence. That has to be it. It's 1/2 the product, that's what divided by 2 means, of n terms, all right, times the first and the last term, times the sum of the first and the last. Now, if you're using the population notation starting at the seed or the first term, this is the first term or the seed, first term, which we call the seed, okay, and this is your last term here, then the formula looks like this, okay? First plus last times the number of terms divided by 2, because we're always double counting. The alternative formula to write this, which probably will make more sense to you because these subscripts are confusing to people, is this one here. And I write it like this just because it makes a little bit more sense to most people. Because the subscript, if we start at 1 instead of 0, it still stands for the first term, but it makes more sense because you start with the subscript 1. P sub n, this is just the last term. So really, what this formula is saying is, hey, take the first plus the last, okay, multiply it by the number of terms, and divide it by 2. All right, take half of it, divide it by 2. That's why it says 1/2 right here, right there. 1/2 means you divide it by 2. So first plus last times the number of terms, that's always n, and take half of it because you're always double counting. Okay? First plus last times the number of terms divided by 2, and that's how you add up any arithmetic sequence series, or a sum of an arithmetic sequence. All right, so let's get used to that. Let's play with some numbers here. So let's write it out here, and get your red pen out, and let's write down s sub n, the first n terms. Oh, now let's just write sum. What the heck, man? Sum, okay, is equal to, all right, first, all right, plus last times number of terms. I think sometimes writing it in English is much easier for people. Not divided by n, but divided by 2, because we're always double counting. Okay? If you want to write it like this, sum equals, all right, P1 plus Pn times n divided by 2. You can write it like that too as well. Okay? However you want to write it. But make sure you do that. Oh, also, stop, pause, note card time. Everybody put this on your note card. All right, pause the video right now. Put it on your note card, and then press play when you're ready. Hey, Jacob. Hey, listen, Meatball. You better do it, man. I'm watching you. I'm messing with you. Okay, listen. All right, here we go, guys. Let's go for it. Okay, so on this one here, we're given the seed, the first term. So this is your first term. This is your last term right here. All right, and the question is, what is the sum of them? Find the sum. All right, and we're going to use S for sum, so just know that I use capital S for sum all the time. All right, so what is the sum of the first 101 terms? Believe it or not, there's 101 terms right there. Because 1 through 100 is 100 of them, plus P sub 0, that's 101 terms. So we have, I'll start off with S here, okay? S for sum is equal to the first term, 25, plus the last one, 1725, times the number of terms. Ooh, let's talk about that, okay? Right here, there's 100 terms. Okay, if we don't count P sub 0. But if you count p sub 0, there's 101 terms. Whoops, got to write it correctly here. There we go. That's right. From 1 to 100, there's 100 terms. If you add the seed right here, p sub 0, and start at 0, not 1, you have 101 terms. So the number of terms in this case is 101, but we're overcounting by double. Okay, we double counted, so we got to divide it by 2. All right, and you simply put this on your calculator, guys. It's a piece of cake. So you take 1750, all right, times 101. Come on, calculator, catch up. There we go. All right, times 101. Okay, let me fix that. You got to press the right buttons. 101. All right, divided by 2 and hit enter. And you get 88,375. So 88,375. Now, my friends, if you had to do that by hand, you'd be there forever, okay? But here you can be done in seconds. Again, it's first plus last times the number of terms, which you have to determine, all right, divided by 2. All right, let's do another one, okay? All right, so again, here there's 20 terms here, but there's 21 terms in all, so you have to understand that. There's 21 terms in all, so we got to find the sum of the first 21 terms. All right, that's called S sub 21. All right, S sub n in general. S sub n means the sum of the first n terms. In this case, there's 21 terms because again, 1 through 20, there are 20 terms. If you start at counting at 0, there's one additional term, so there's 21 terms. That's the only kind of tricky part in this lesson right now is that right there. So you have to know how many terms you're adding. Okay, so first plus last. So 700 plus the last one, 560. Come on, Ainsworth. 560. All right, times how many terms there are, 21. And since we double counted, we got to divide it by 2. All right, and then you figure this out. All right, so clear out your calculator. 700. If you're using a T84, I would use parentheses. All right, that's probably the easiest way to do it. So 700. If you don't, you're going to have to hit the equal button after the 560. So plus 560. Close out the parentheses or hit the equal button if you're using a regular scientific calculator. If you hit the equal button, you get 1260 times 21 divided by 2. And you should get 13,230. So 13,230. There's your total sum of the first 21 terms. Okay, not bad. Okay, let's try it again. So once again, from the first term to the 13th term, there's 13 terms. But if you kick in the seed there and you add that in, there's 14 terms. All right, so you got to be very careful on how many terms you're looking at here. So if you want to find the sum of the first 14 terms, here we go. First, it's 5 plus the last, 70, times how many terms? 14. And we double counted, so you got to take half of that. So once again, clear out your calculator. You got 75 times 14 divided by 2. All right, and you get 525. It's very, very simple once you get the idea. You just have to know how many terms you're working with here. Okay, let's try it again here. Now this one here is a little bit different, right? So let's take a look at it. We know the first term, we don't know the last. We don't know P99. You know, what is this right here? You know, we know this one. We know the first one. Oh, we know actually we know the we know the C23, but we don't know the last. Ooh, we don't even know let's see here. P100. Oh, we got to figure this out. Okay, so we don't know P100, we don't know P99. Okay, so we're going to have to figure them out. What in the world are these terms, right? Okay, so let's use our prior knowledge, okay? So we know that P sub n is equal to P sub 0 plus D times n. We know that because we know from the prior lesson. We know this. Okay? So because of that, we can figure this out. So we know that, I love saying that we know, it sounds so powerful. We know that p sub n equals 23 plus 7n. So that's called the explicit formula. That's from the prior lesson. We're building up skills here. Okay. So what we want to do now is use it. So let's use it here. We're going to find P100, okay? Because we don't know the first and we don't know the last. So we got to find them. Here we go. All right, P100 is 23 plus 7 times 100. See, this is a basic skill from the prior lesson. That's 723. P99, 999, what's that? Well, it's 23 plus 7 times 999. What's that? Well, if you don't know it, figure it out, right? Get your calculators, guys. Just don't sit there, copy notes. Figure it out. 999, all right, times 7 plus 23 more. All right, 7,016. Okay, so we consider this right here to be the first and that the last. Okay, so I know it says P100, but this is the first term that we're looking for in the summation because we're not starting from the P0. We're starting at the 100 term. So this is the first, and this is considered to be our last. All right, so understand that. So here we go. We're going to sum well, how many terms? How many terms are there from 100 to 999? How many terms? You got to know that. How many terms are there? We'll ask that. Okay, so in fact, let me just erase these little things. So how many terms? How many terms? Question mark. We'll figure that out. Okay, so S sub, well, we got to answer that now. So how many terms from 100 to 999? 999. And you got to be careful though, because if you just subtract 999 minus 100, you get 9 or 899, right? But that's the wrong answer. Okay, there's more numbers than that. So let me go off to the side a little something here. Let me show you something. Let me find some room. Ah, there's some room right here. So come over here, guys. Okay. Okay. So let me take a little side problem here. Instead of figuring out that right there was kind of tough for some people, let's make it a little smaller. How many terms are there from 1 to 5? So 1. Okay. Whoops. 2, 3, 4, 5. How many terms are there? Is it 5 minus 1 or 4 terms? 5 minus 1 is 4, right? But here, there's 5 terms. So you got to be careful. If you subtract the last minus the first, you get 1 less than what you want. Because there's obviously, from 1 to 5, there's 5 terms. So you can subtract, but you better add 1, okay? In other words, there's always 1 more than the difference, okay? So 999 minus 100 is 899, right? Plus 1 more, well, that's 900. There's 900 terms. Think about it. Okay, so we got to add the first 900 terms. So that's called S100. There's 900 terms from P100 to P99. It's always the difference between the subscripts plus 1 more. I'm talking about right here, plus 1 more. Okay, so here we go. First plus last. So we take 723 plus the last one, 7,016, multiplied by how many terms we have, which are 900, and because we double counted, we got to take half. And we do this on the calculator again. Okay, that's why I said bring one to class every day. So be responsible and make yourself successful and participate and make your life a lot easier by bringing your calculator. Okay, so look at this, 3,482,550. Okay, so let's write that down. So 3,482,550. You guys, that's an easy problem if you know your skills from the prior lesson, number 1, have a calculator, number 2, and use the modern methods like this. First plus last times the number of terms. Okay, first plus last times the number of terms. divided by 2 because you double counted. So you have to divide by 2. Okay? Use your red pen, annotate well, and your life becomes easy. All right, this next one is just like what I just did. So let's do another one to get some experience because that's what you guys need. Okay? So the first thing is let's figure out how many terms. Okay? So 199 minus 100 is 99 plus 1 is 100. So there's 100 terms. There's always the one more than the difference. So you got to subtract them and add one more. So there's 100 terms. That's n. Okay, we don't know P100 and we don't know P99, so we got to figure it out. So the very first thing is I write my explicit formula. Okay, I'm talking about this one. So let's write it out. So Pn equals the seed, all right, plus d times n. You guys already know that. So P sub n is equal to 23 plus 7n. From that, I get P100, which is 23 plus 7 times 100, 723. I need P199, and that's 23 plus 7 times 199. This one's a little bit tougher, so use your calculator. By the way, this is a video, right? So if you're at school or at home, press pause if I go too fast, because I know I do for some people, okay? So 23 plus 7 times 199. All right, you get 1416. So 1416. There's your first and last. So let's sum up the first 100 terms. That's called SM100. So you take the first 723 plus the last, multiply by how many terms, which in this case is 100. Divide that by 2 and work it out on your calculator. So here we go. So 723 plus 1416, 1416. All right, hit equals or enter, times it by 100, divided by 2. Okay, 106,950. So 106,950. There's your sum of the first 100 terms. Sum of first 100 terms. Wow. I mean, that's amazing, okay? And you could do it easily. First plus last times the number of terms divided by 2. Use your red pen. First plus last times the number of terms, which is, n in general, all right, divided by 2 because we double count each time. And that's all there is to it. Well, no, I'm just kidding. That's not all there is to it. There's more to it, okay? But we're going to pause right there and reserve all this for the next video and the next lesson here. Okay? So what I want you guys to do now, let's see. You can start this homework right here. Ha. You can start this because guess what? To find the sum here, you have the first and you have the last. Oh, you got to find that. Oh, okay, don't start that yet. Okay, wait for me on that one. You could probably... Oh, you can start your homework. Okay, so start your homework now. Let's do that. So I'll finish the lesson tomorrow. You start your homework here, 11 through 16 on the last page. Okay, start working on that. And as I finish the lessons, you could finish your homework. And when I finish the lessons, and after I finish the lessons, finish the homework and we'll all be done. Okay, so this next set of material right here, these next few examples, starting right here, will be the second part of the video in part 2. And I'll do this tomorrow. We'll finish up tomorrow and then finish up our homework. But again, turn to the last page, start your homework, and I'll see you in my next video on linear arithmetic series, summation of the series. All right, here in part 2. This is Mr. Ainsworth. Sign off now. Make yourself proud and do your work daily in practice. I'll see you next video. Bye-bye.